Well, good evening, it's TOG time again, and we're going to be playing the footage of TOG-1 during her October 1940 trials, and while I'm doing that I'm going to give you a rundown of the early testing of TOG-1 before she becomes TOG-1A, and then we'll go through the trials video and we'll pick out some key points from that as well. So just to recap, we have TOG-1 from development. She gets ready all the way up through the middle of 1940 to get ready for trials in September. The SVDC at this time already have finished their attempt on working on an amphibian. So now they have only to concentrate on TOG-1, which is all but finished, and TOG-2 going forwards. Now, small components of TOG-1 were being tested on the 11th of September 1940. Each side of the tank was run in turn through the sprocket without tracks fitted. They actually used a welder's motor for this rather than the engine or electric motors. With the tracks fitted, tests began on the 23rd of September, which is technically ahead of schedule, and unfortunately was a disaster because the engine suffered a cracked offside water outlet manifold at the number 5 cylinder A bank. It was a temporary problem, and it seems to have been a manufacturing fault with the engine rather than a fitting or design fault. In fact, the vehicle was running just fine just a couple of days later. On the 27th, in fact, she was weighed in, and simply because she was so big, she had to be weighed in halves, so they weighed her in two halves, the right side and the left side. Now, the right side weighed 36 tons 1400 weight, meaning a total of 72 tons 2800 weight. At 2000 weight per imperial ton, that's a total of 73 tons 800 weight. That means she was overweight. The official weight at the time, recall, was meant to be 68 tons, but the official weight is for the turretless machine, and this machine now had a turret, so this slight increase of about 5 tons 800 weight is not as bad as it may seem. Indeed, she was soon running around just fine on William Foster's test ground, and during test number 6 she went over the railway lines at Rushton's Corner and actually caused damage to one of the near-side track links in doing so. The result, however, was that everything was ready for TOG-1 for formal trials on the 4th of October 1940. 4th of October 1940 was a fine Lincolnshire day. The vehicle was fully closed up, bar the side sponson holes, for which a decision had yet to be made, and TOG-1 successfully completed circuits of the test ground for the invitees to witness. This was done without issue, including a traverse of the prepared trench, covering 2 built-up embankments with a depressed section in between, measuring 30 feet across and full of water. The water was just 1'6" deep, and the surface level of the water was 3 feet below the ground level. The sides of the embankment were 35 degrees. A series of other obstacles were also sketched but not constructed. It can be theorized that these were drawn out for some potential future tests. The first of these was a 3-foot mound with a drop into a 3-foot deep trench of water, 30 feet long to a shallow exit. The second was a 3-foot high mound with the same 30-foot wide water-filled 3-foot gap to a small exit mound with steeper sides to the trench, and this would serve to check the maximum climb angle of a vehicle. A third trench had a steep front embankment 3 feet high with a 6-inch thick hardened face and a very steep downward face on the other side into 30-foot wide water trench, and a steep 6-foot bank on the opposite side to climb out. A final obstacle was what appears to be a pair of large rectangular blocks made from brick walls 4 feet high and separated by a 20-foot gap, with the intervening space made of flat, loose cinders. This would be a good trial of how a vehicle could exit complex anti-tank obstacles. A final obstacle sketch is simply of a wall 6 feet high and 2 feet thick. None of those, however, appear to have been present in the 1940 trials. TOG-1, in fact, during the footage, of the water obstacle appears to traverse the double bank and water ditch sideways, and yet it is still dropping nearly 6 feet or so into the pit. Judging from the height of the bank to its right as it crosses the ditch, the embankment proposed was even more severe than anything drawn, with a facing bank perhaps 6 feet above ground level and dropping the TOG-1 into a ditch from even higher up into the water. The height of the exit bank cannot be easily judged from the footage, but TOG-1 can clearly be seen crossing the obstacle in the other direction too, over the huge bank, into the pit, and up the other side at an angle of perhaps up to 45 degrees. Certainly anyone witnessing these trials would have had to have been the most hardened skeptic or cynic not to be impressed by such a huge vehicle crossing this otherwise impassable obstacle with consummate ease. The same is true of the anti-tank ditch, which appears to be 10 to 12 feet wide and once more is crossed without issue. Visible at this time on the sides of the vehicle is a simple device called the inclinometer, consisting simply of a free-hanging white painted stick which changes position with the inclination or declination of the tank as it goes up or down, and the half moon below it denoting which angle the stick was at, showing the angle of the slope. This is a common and old practice, and indeed can even be found in an old picture of tractors being tested for World War I. After this, other trials were then shown, including passageway over a large heavy bulk of timber, and a rotation test of TOG-1 on the ground. This is October, and it was a good day, but the ground was not yet frozen, and yet still this overweight vehicle made little impression in the ground, other than from the rotation of the track spuds in the dirt. There was, post these trials, plenty of work ahead, including a desire to remove what was called superfluous equipment, although nobody on the SVDC could agree with each other on anything to take off the machine. The only notable thing, in fact, seen in the trials removed later is above the driver on the hull roof. This is a triangular fitting of some tubing of some description, which appears to be either a part of a sight or ranging system for the hull gun, or perhaps more likely some kind of periscopic system to assist the driver. This was not only vulnerable, whatever it was, but unnecessary and removed. Noteworthy is also the large square hole at the front for the driver. As yet, the driver's vision plate had not been fitted, and the assumption would be some kind of large cast block with a slot in it to be added over there, very similar to the Shah B. There were flaws outside of the tests too. Sir William Tritton wanted the machine to be lighter. The engine, for example, he felt took up too much space, and the accessories took up 250% more space than the engine. A specific fault was that the pump for the fan drive gearbox required drowning in oil to stay lubricated, and also a lack of cooling air. New vents would be needed to supply enough air under pressure to keep things cool. That said, Mr. Tritton was very pleased. The machine had worked perfectly, and he remarked that it could easily be made 2 feet shorter than it already was with zero mechanical changes or difficulty, notwithstanding the requirement for crossing a 15-foot trench. Tests of the electrical equipment on TOG-1 started on the 7th of October by Mr. Inglis, and these revealed that the tachometer was showing a higher value than it actually delivered, effectively meaning that the engine was not being run fast enough for the tests a couple of days beforehand. A new tachometer, a Holzer 5155 model, was fitted, and then brake tests began again, increasing the current by 7.5%. This change in the current led to a decision to leave the brakes off until other tests were completed, so the current changes from the use of the brakes would not interfere with those tests. This remained unfixed until a chap from Mrs. Bendix fixed them between the 9th and 10th of October. Finally, the overspeed trip gear was recalibrated between the 8th and 11th of October, with another test taking place on the 10th, before it had been refitted. The control gear was also modified on the 11th, and rigorous testing was carried out on the whole system all the way through to the 22nd of October. One minor change of note was the addition of 2 temporary electromechanically operated steering connectors on the back These would allow the shunt field current to be applied to the generators and motors without having to close the exciter. This was purely for the test of the regenerative braking system in operation when running the tank downhill. Finally, on 22nd of October 1940, test number 20 of TOG-1 was to start looking at water temperatures for the radiators. The vehicle at this time was still being regularly driven up and down the workshop and on the test ground, until a decision was taken to mess with the suspension. The 6th of November. Covers were also fitted, deliberately blocking the air intakes to try and make the engine and other elements overheat as part of testing to improve the cooling. For the rollers, however, after just 13.1 miles, rollers 18 and 19 were broken and had fallen apart and needed replacing. In fact, new rollers were fitted again, except all the rollers this time would be of a 12-inch diameter, and this time a mix of the soft rubber ones, including half of them being taken from TOG-2 and the other half reverting to cast iron. Indeed, one of these iron ones would later crack, needing fixed, and the tests on the cooling system also identified the need for bigger fans and reworked vents. As the strain of increasingly difficult tests continued, the joints in the cooling system were put under increasing pressure, and this produced leaks. High pressure joints and seals would then be added as part of the work towards a pressurized cooling system. For the suspension once more, new rollers were fitted and tested between the 9th and 10th of December 1940. Rollers 17, 18 and 19 had broken away. These were all cast iron ones, and they broke after just 43 miles, showing it was not just the weight of the cast iron roller which was a problem, but also the vibration and load causing more problem than the improved rubber type TOG-2 rollers. One cast iron roller at the number 10 position indeed ended up being changed for a machined steel one, and the rubber rollers were also showing problems. The changes to the cooling system would eventually be incorporated in the TOG-2. These would include a new fairing, insulation of the exhaust passages, the addition of an aircraft radiator to improve cooling and reduce weight, and to incorporate the new pressurized cooling system. TOG-1 over those weeks had got new radiators, new air ducts, brakes, control gear, and a new set of rollers again. These now would be a mix of thicker cast iron types at positions 12, 17 and 18, and soft rubber ones, and a new forged steel one at position 10 and 19. These were all 12-inch diameter rollers. Weighed again, she now came to 36 tons 600 weight for a total of 72 tons 1200 weight, meaning that now not only was she using a better cooling system and control system, as well as improved suspension, but she'd also shed around a ton in weight during just a month and a half or so of testing. She was, at this time, still doing daily tests, having run a total of 88.7 miles, and Sir Albert Stern was now even wanting more armour on the vehicle simply for the purposes of trials. Now, on the 9th of January 1941, more trials showing off TOG-1 were carried out for the military on the training field, and the only fault at that time was a broken belt on the odometer, which obviously no one would get to find out about. She had, by this time, cost £14,765. In 2021 values, that's around £750,000, which seems like a lot of money, but really isn't. The tests also seem to have made up the minds of the attendees, and they sparked a decision, finally, from the Army on those missing sponsons, because on the 17th of January 1941, TOG-1 was finally formalised in plans. That's 580, 581 and 582G, using small, angular machine gun sponsons, so 2 bases on each side, with a notable blank space in the front hull for a gun, suggesting that once more not only could the 75mm French gun suffice, but that alternatives were still potentially on the cards. Probably the most obvious choice being something like the 25-pounder, or if they have a stock of something ancient to go in there. The sponsons would increase the width, but they would also be removable or foldable for transport. So TOG-1 total width for transport would be just 10 foot 3 inches, well within the rail gauge. Despite working well then, TOG-1 was clearly an increasingly obsolete design, yet still gaining some interest. And even with the idea for the French type Char-B cast turret instead of the A12 turret for the vehicle, it was still clearly not the design the SVDC wanted. The vehicle speed was still going to be poor. Okay, it's going to be in excess of the RBM 17 requirement, but 5 to 5.5 miles per hour at 75% capacity off-road. So potential top speed of perhaps at most 8 miles per hour was not fast enough for the team. They wanted more, even though the requirements did not call for more. TOG-2 at this time was already being designed and readied in order to provide a top speed of 8.5 to 9 miles an hour as a heavy tank. And yet TOG-3 already at this time is being proposed at 12 miles per hour, putting it in medium tank speed territory. So the 5 to 5.5 miles per hour off-road of TOG-1 was not going to be acceptable to the team. They wanted more. Now, daily testing of TOG-1 would end up restarting in March 1941 with an odometer reading of 140 miles, and Mr. Weir, chairman of the tank board, even recommended TOG-1 to go forward, producing data along with TOG-2 in preparation for the TOG-3 design. Considering the parlous state of the A-22 program at the time, TOG-1 and TOG-2 were proving to be very promising concepts and working in excess of expectations based really on nothing more than a preconception by some of big tank bad. TOG-1 would continue to find use and modification as it moved into TOG-1A, but for now, having proven their concept and proven their ability to design and build a tank, the SVDC's attention was going to be drawn to the TOG-2. That tank derived from what they had originally wanted all the way back in October 1939.
Okay, so now let's take a look at TOG-1 trials footage. So 4th of October 1940, we have a very nice Rolls-Royce there at the back, and the other dignitaries' cars inside the wooden sheds behind TOG-1 on the flat surface here. She's heading towards the anti-tank ditch. This is William Foster's test ground. Pay attention to the inclinometer at the back. It's currently showing it's on a flat surface. As it crosses the anti-tank ditch, down she goes a little bit, reaches the other side, uses her great length, which is why she was designed the way she was, reaches up to about 30 degrees at one point, and carries on. At the back there in the pale coloured trench coat and cane, we have Sir Albert Stern looking very pleased with himself, as he should. Two things to have a look out for on the vehicle. Next to where it says TOG-1, you'll see a black letterbox. There's another one at the back. Those are actually mud chutes, and if you pay really close attention, you can actually see some mud getting squirted out through those at one point. Those are not unarmoured, so those wouldn't be a weak spot in that sense. There's actually armour behind there, but that's what those are for. Those are a Sir William Triton thing, those mud chutes. Now, we can actually see the vehicle traversing the water obstacle. This is a 30-foot wide water-filled obstacle, and he's traversing it sideways. Now, there's no bank to climb to get in and no bank to climb to get out other than the sides of the hole. The banks are actually on the left and right of the picture as you're looking at it. You can actually see the slope of one of them to the left of the image there as the tank goes in. We also get a view of the roof of the vehicle. We can see the raised sides covering the sides of the air intake. We can also see episcopes on the roof, and on the front there, two headlights, and right in the middle a car horn to warn of the approaching TOG for any motorists who might need alerted to it. We also can see the exhausts on the back there. This is a top secret trial, so that's no doubt why that gentleman brought his child to view it. Back up to the obstacle one more time. This time we're going through the obstacle backwards, so to speak. because we are going over one of the banks down into the water obstacle. Now they're going to go slowly over this. The engine is located roughly centrally. We have armour on the front and all of the mechanical gubbins at the back. Trying to find the centre of gravity, which is roughly central. Down into the pit, the inclinometer there flops to about 40 degrees. Look how difficult that bank would be to any other tank. That inclinometer is already at 30 degrees, 40 degrees as it's coming up the bank there. And yet there it goes, all the tracks moving quite nicely without enormous difficulty. Sure enough, not fast, but that is an otherwise impassable object for any other British tank at the time to cross. Back to the anti-tank ditch, we have another view of it. Crosses it with just consummate ease. There's no problem crossing that gap whatsoever at the time. Then wheeling to the left. The gentleman inside showing his comfortable ride for the vehicle. We're not bouncing up and down, even though there is no suspension. Remember, we're still on the original cast iron rollers at this point. Now, back to the water obstacle again. Pay attention this time to the side hull below the sponson hole. The water here is a 1.5 feet deep. You'll notice the water doesn't quite reach the floor level inside, so that's about 2 foot up. So obviously at this time there was still yet to be made a full decision on whether to just armour it or whether to have some kind of sponson. Crossing a typical sort of battlefield obstacle, like this timber bolt, we also get to see up close the damage to the track link which took place just before these trials when the vehicle hit the railway lines at Rushton's Corner. The purpose here is to stress out each roller in turn, as each one has to bear basically half the weight of the vehicle. Now, look how deep that ditch is. Almost the entire hulk of TOG-1 is hidden, and there, 45 degrees maximised on the inclinometer as we come up over the top, and yet she's still managing it magnificently. Now, we are on the surface, and we're going to show another little feature of TOG-1, and that's its neutral turn. The right track is going forwards, the left track is going backwards, and the result is an anti-clockwise rotation, and vice versa here, left track forwards, right track backwards, and a clockwise rotation of TOG-1 on a flat surface. This is a November day, the ground is not frozen, and yet there it is. Despite what people might want to think about such a large, rather ugly and ungainly tank, a 70+ ton tank, there is no denying that it does not sink into the dirt as they may wish to believe. This is an agile vehicle for its size. The ridges that can be seen are simply a function of the spuds in the tracks being pressed into the ground and rotating. So what that shows is that the design work on flotation, making sure that the tank doesn't sink into soft mud, was indeed paying off. You can see that the ground is relatively soft, and yet there it is. The tank is simply not sinking in as some people may wish to believe it would do. It's not hard to see why the team are so rightly proud of the vehicle at this point. Now, have a look here where the dignitaries are examining the vehicle up close, just how big some of the features of this are. One of the reasons this tank is not sinking in is just the width of the tracks there. We have the design team up close with the vehicle. You can see it's a high vehicle, the hull is over 6 feet high. With the sponsons off, it's actually 10 foot, and up close you can see the width of the track links itself. So that is why it's spreading its load so ably. These are obviously the older World War I style bolted together links with a foot to which a plate is riveted. These were already to be replaced with a cast type link of the type you'd like to see on TOG-2. And, the team are rightly proud of it. That's Sir Albert Stern there, again, with the cane, with Sir William Tritton shaking his hand. A magnificent vehicle, and, quite rightly, proud of everything they have achieved in demonstrating, perhaps to the chagrin of others, that this vehicle was actually capable. And no demonstration would be complete without some little demonstration of tensioning the track. This is that same First World War style track tensioning screw system, so that's what they were doing. And nothing says how pleased you are like having the camera record you all having a nice chat, give the gun a slap, have a laugh. I do not know what medal that chap is wearing who's sat on top of the gun. If someone does, please do let me know. That would actually really help my research later on. And despite the size of the vehicle, here as she comes into the shed, if you were the enemy, and this is all you get to see of it, you actually have a relatively small target. I mean, nearly half the width of the vehicle is just tracks. You have a relatively small target to aim at. We know the A12 turret, that Matilda turret on top, is 3 inches thick, and that Glacis is also 3 inches, and you've got the 75mm hull gun. It's a small and it's an agile target. So thank you very much for having a look at that. I hope you found that footage useful and interesting.
Well, that's it for now. There's another episode being prepared, and another project to start as well, so maybe that'll be the next video rather than just continuing purely on TOG alone. If you do like this video or any of my others, please do the usual business that people ask, and most importantly, please share this video with other people so they can link into the series, so they can start to genuinely learn accurate information about the TOG development program. We need to fight some of these stupid memes that are around, and also a general level of knowledge on the program which needs improved on. So please do share that, please like this video, and if you do wish to support this channel, please follow me on Facebook or WordPress, my author page on Amazon, or FWD Publishing. And there is also a Patreon page as well. Thank you very much. Good night.